Hello everyone, and welcome back to the garage. Today I have a tube radio restoration video for you guys, but this one's going to be a little special. It's not going to be on a tabletop tube radio like this one here, and if you see my videos, I just restored this one and I got it working perfectly, so go ahead and watch that if you haven't already. This time we're going to restore a proper console radio that would have been purchased by someone back in the day and used as their primary form of entertainment. This radio is a Wards Airline 7-tube radio from 1935. So it's 91 years old and it was made before World War II. And believe it or not, I found this radio at my local Goodwill. It was sitting right up in the front, and as soon as I saw it, I was like, oh my gosh, hold everything, I'm gonna buy this right now. Because how often do you see a console 1935 radio at a Goodwill? You don't. So I made sure to grab that as soon as I saw it, and so it is now here with me, ready to be restored. And as you'll soon see, this radio is in very good shape for being 91 years old. And I took a look in the back, and it seems like it's complete. Everything looks like it's there. So I think we can get this thing restored back to how it worked 91 years ago. So let's get started. All right, here is the beast. A Wards Airline console tube radio from 1935. And this thing is in very good shape for being 91 years old. It's got a little bit of wear on the top, as you can see, and it's got some paint splotches. I'm assuming this sat in someone's garage for a long time, so it's had some paint spills on it over the years, but looking at the whole thing, it's not that bad, especially the dial. Look how nice it still looks. I can't tell if that's plastic or glass. It feels like glass. It sounds like plastic, but the text on the dial is very nice still. Even the red text, because red likes to fade quicker than other colors, is still visible and readable. So this thing must not have been sitting in direct sunlight, and that kind of saved the dial on this thing. All the knobs are here, and they all turn, including the tuning dial, and because the needle's turning, we know that the dial string is good. And so that's a major thing we don't have to deal with. And all the other knobs are nice and free as well. So the potentiometers are not all seized up. They all still feel very nice. So I don't have to do anything for that. And the front mesh in front of the speaker is still in very nice shape. I mean, there are no major tears in it whatsoever. So obviously this radio was taken care of when it was actually used. Maybe not when it was sitting forever, but if it wasn't taken care of, the mesh would not look like that. And of course, it's got some wear on the bottom because it's the bottom. It's going to be slid around and bumping into stuff. But for 1935, you would expect it to be a lot worse than this. And so I'm glad to have found this thing and saved it, because now I'm going to be giving it a second life and it will receive radio stations once again. So here's what it looks like in the back. And as far as I can tell, this radio didn't have a cover on the back. It was always exposed like this. Someone put a little blanket here for some reason, and that's kind of dangerous because it sits right next to the chassis, and the tubes get really hot. And so if they happen to touch this, it could potentially start a fire. So I'm going to be removing that. And here is the chassis of our radio. And looking at it from the top, it looks to be in pretty good shape. There's no serious rust or corrosion. And I think all the tubes are there. There's two here, and there are tubes inside these little cans as well. I haven't pulled it out yet, so I haven't been able to look at the whole thing, but from what I can tell, it's pretty nice. This is a model 62-175, and it was approved by the RMA Engineering Institute. So that's kind of interesting. And right here we have a Wards Airline radio plaque says only the finest quality of parts are used in this radio. And of course, it was made in the USA. So this thing is probably no slouch in terms of performance and quality. And I found this little antenna wire inside it, so I'll probably hook that up to use as my antenna for when we eventually test this thing out. And down underneath the chassis, we have an absolutely massive speaker. That thing's got to be like 12 inches diameter. And it's got a huge voice coil. Look at the size of that thing. It's made by Operadio. So I imagine this thing is going to sound really good. And I took a look at the speaker cone and I didn't see any tears in it. And I moved it ever so slightly with my hand just to see if it was free, and it is free. So I don't see anything wrong with the speaker. I'm pretty sure it's going to just work. And you can see we have our audio output transformer screwed right into the speaker itself. So that's where that is located on this radio. And here we have two wires, and they are labeled antenna and ground. So I'll have to figure out where those go. And I don't think this is the original power cord, because if it was, I imagine it would be as hard as a rock and would crack the moment you tried to bend it. This one is still very soft and pliable, so I imagine it's been replaced at some point. And here we have a little connector plug that goes from the chassis down to the audio output transformer and speaker. And so that is the little pass-through that gives power to the speaker from up by the chassis. And so if you've watched my previous radio restorations, you know that I am someone that likes to do things the right way. So what you're not going to be seeing from me is plugging this radio into the wall right away to see what works and what doesn't, because I don't like to take chances with this kind of stuff. So how we're going to do this is I'm going to check all of the capacitors underneath the chassis and these two big cans on the top of the chassis, and we'll see if they're leaking. And if they are, I will replace them with brand new capacitors. I'll check all the resistors, and if I find any that are bad, I will replace them. And I will go through and test all the tubes and replace any that are either bad or weak. And all of that will be done before this radio even receives power. And if you're new to tube radios or tube radio restoration, you might be wondering, well, why can't we just plug this thing in and see what works? Then we'll know what we need to replace and what to deal with. Well, you will see as I take this thing apart and test things that that is not what you want to do. And I will show you all of that once we get into the deep end of this thing. So the first thing to do is to remove this chassis. Let's take a look at what we're dealing with. So I'll go ahead and disconnect the speaker and the audio output transformer. I'll remove that plug. Looks like there's just a screw to remove to take this interlock out of the way, and then I should be able to just pull this out. And then there's some screws underneath the chassis that hold it in, and then I'll be able to just pull it out and we will take a look at the radio itself. Well, it is missing several screws underneath the chassis, so I'll have to get some replacements at some point. I'll just go ahead and pull the ones that are still there out. There it comes. There we go. All right, here is the chassis pulled out of the radio. So now we can get a better look at what it looks like. You can see we have some more tubes back here. And I imagine that these two tube sockets are supposed to have little tube covers like these two. And I think these are designed to reduce interference to the tube from other parts of the circuit. So maybe I'll try to find a couple of these, but for now we're just going to leave it as is. So it looks like we have all the tubes, each socket has a tube in it, and everything looks to be in decent enough shape on the top. We have a big old power transformer right there, so we're going to hope that works. It probably does. But what I'm more worried about are these two humongous capacitors right here. These, without a doubt, are going to be bad, but I'm going to run them through my leakage tester and we'll see just how bad they are. And I haven't looked at the schematics yet, but I would imagine that these two cans here are the two IF stages. And then here we have our tuning capacitor, and it looks to be in nice shape as well. And this radio, from looking at the pointer, it does not use a dial string. It uses friction. And so when you turn the tuning dial, it turns this plastic wheel, and that's what spins the dial. So there's no string involved in this radio. You can see it's going through some foam pieces right there, and those are actually still good, which is amazing. And then there's a little soft piece between the shaft and the rest of it back here that the plastic wheel is inside of. So that's how it turns when you turn the tuning knob. And you can see it's working just fine. So I don't have to deal with that. I'm not going to touch that or do anything to it. I'm just going to leave it alone because it works. And the dial does have two dial lights, so I will put those under my power supply and see if they're burned out or not. But here is what the top side of the chassis looks like. Looks like it is in very nice shape and it'll clean up really good. Let's go ahead and take a look underneath and see what we're dealing with there. And I'm going to be careful when flipping this around because the little plastic wheel for the dial assembly is the highest thing on the chassis, so it's going to rest right on that. And so I am going to likely end up propping this thing up with something when I'm working on it, but for now, I just want to see what the underneath looks like, so I'm going to go ahead and flip it over and see what we got. Oh, it's been worked on. Lovely. So someone has been inside this radio before, because as you can see, all of the capacitors have been replaced with modern film capacitors. And there's a couple new electrolytic capacitors right there. So this radio has definitely been worked on before. But I still saw some things I didn't like there's a capacitor lead right here that is very close to touching the metal on the tuning capacitor assembly, and that is not good. So I'm going to have to desolder that and put some heat shrink over that lead. And I see that this dog bone resistor is soldered to a cap lead. I don't really like soldering components together like that. I would prefer to have them both go to the lug on the tube socket. That way we don't have any joints that are just kind of hanging like this. So this radio still needs work because I'm going to have to go through and see if the values they put in are correct and if they even put them in the right spot. And so that's where the schematic is going to come in really handy. And I see that the feet on this radio are still original because they are cracking like crazy. So eventually I'll come up with a solution to replace all of those with brand new feet, and so they'll all be the same. And I did see that the two large capacitors down here were taken out of circuit, so that's good. And I assume that these are the replacements for those two. So in this radio, we're not going to have leaking capacitors because they've all been replaced with modern ones, but we do still have original dog bone resistors, and I didn't see any replacement resistors, so I still need to check those. And of course, I need to check the tubes to see if they're correct and if they are strong. And after looking through this chassis a little bit more, there are quite a few things that I would have done differently when restoring this thing. So I'm just going to approach this like a regular radio restoration. So the first thing I want to do is test the tubes. And when I looked inside this radio for the first time when I brought it home, I found this, the original reference diagram for the tube locations. And it is supposed to be stuck inside the radio, and I know exactly where it came from, so I'll go ahead and stick that back down when I'm done referring to it. So I thought that was cool to see still in there. And so since this radio uses a bunch of older style tubes where the pins are really large, my solid state tube tester isn't going to be able to test those. So this is my older tube tester from the 60s that is able to test those kinds of tubes. And this tester is a Knight 600 series tube checker, and it's definitely seen some use, but it is fully working. So we're going to go ahead and use this to test all the tubes out. And I just went ahead and pulled all the tubes out of the chassis, and they are all correct. So that's good. I don't have to do any replacement tubes yet. So we have 7 tubes. Let's test each one and see how well they fare. So the first one we'll do is this one. This is an 80, and it is used as the rectifier tube in this radio. So this tester isn't the most intuitive if you don't have the manual, so I am referring to that because the 80 is not in this little quick reference that it has. So it says that an 80 has 2 different sections that we need to test. So to set this tester up for an 80, I need to set the A circuit dial to 3. The filament voltage needs to be set to 5 volts. So it only takes 5 volts to heat up the filament in this tube. I need to set the load dial to 48. So right there. And I need to put lever 2 up and lever 1 down. And so now we can go ahead and power on the tester, and we should see the tube glow after a few seconds. And I may have to adjust the line voltage so that it reads right in the middle. So about right there. And it's very faint, but I do see filament glow in the tube, so the filament is not open. That's a good sign. So what I want to do first is check the tube for shorts. So you can see right now the shorts test lamp is not glowing, so it's not detecting any shorts right now. And on this tester, how it works is for the levers that are still in the center position, there will be certain levers marked for the specific tube that if you flip them up, it'll make the short light come on, which is normal. So for example, say I'm testing a 6BZ6. This is just what I have shown right here. And you see how it has the number 4 in parentheses right there? That means that when you're testing that, number 4, if you flip it up, it should make the short light come on. So for my tube, it's also number 4, and it's just number 4. So if I flip number 4 up, you can see it makes the short light come on, and that is normal. And if we were to do that for all the other ones, the short light should not come on. And you can see they don't. So the short test passed, because if any other one of these levers were to make the short light go on, then we would know the tube would actually have a short. So this tube has no shorts. So the next test is the emissions test, and this is the test that will tell you if the tube is strong, weak, or bad. So all we need to do is just hold this switch down in the value position, and the needle should go up into the good for the line test scale. So let's see what we got. And yep, that is a perfectly healthy tube. That first section tests very strong. So that part of the tube is good. So now let's test the next part of the tube. So I'm going to go ahead and turn the tester off so that I can make all of the adjustments for the second section. And so the only thing I need to change is to put this up to 54. So up just a little bit. And instead of lever 2 going up, lever 3 has to go up. And so now this is going to test the other section in the tube. And so the shorts test on this section is the same. Number 4 should make it go short, and it does, and none of the other ones should. And if we see the light come on from any of these other ones, we know that there is a short. And you can see there's no short. And let's check the emissions of this section. Perfect. So this 80 tube is absolutely fine. It can go right back into the radio. And so the next tube we'll test is this one. This is a 6F6, and on the radio diagram, it's labeled power. So I assume this is like the power audio amplifier tube. And with all the tester settings correct for this tube, let's go ahead and see if the filament glows. And I can tell that it's doing something because the line voltage is very high. I see filament in there, so that's good. So for the shorts test on this tube, it should be lever number 7 that makes the short light come on. So this is 7, and it does. And then we'll go ahead and do the other ones. They're in the center position just to make sure. And the tester does say a brief glow like that is normal. All right, so this tube is not shorted. Let's see what the emissions are like. Wow, that's a very strong tube. It's pegging the meter. So that one's good. And for this tube, we also have an additional test. We have the gas test. So for each tube, the gas test is a little bit different. But for this one, what we need to do is hold the switch in the value position like we're doing an emission test. And we need to flip lever number 4 into the center position. And then that will that will switch it from the line test scale to the gas test scale. And so if I hold this down, that's the emission test and it was reading good. So when I flip number 4 into the center position, it should go into the good on the scale below. And it does. And that means there is no gas leakage inside the tube. So that's good. The tube is just fine. It can go right back in the radio. The next tube we'll test is a very important tube. This is a 76, and it is used as the oscillator tube. So when you're receiving radio stations, there will be an oscillation happening. And when you tune the radio to different stations, the oscillation will change, and that all comes from this tube. So we're going to hope that this tube is good. And with the settings correct, we'll go ahead and turn this on. And I do see filament out of the tube. So for this one, the shorts test, the lever that's going to make the light glow is number 5. So let's see if that happens. It does. I'll go ahead and turn that back up. And none of the others should make it glow. Perfect. And then we'll do the emissions. Perfect. Nice and strong tube. And the leakage test is going to be lever number 3 flipped into the center position. So we'll hold this down, flip number 3 down. You can see it's in the good. It's not fully in the good, so maybe there's an ever so slight amount of leakage happening, but it's still in the good for the gas test. So this tube is absolutely fine. It can go right back in. Next tube is a 6B7, and it's used as the second detector tube. And this tube is a triple section tube, so I've got it set up for the first section. We'll see if the filament glows. And yep, I do see it. It is very faint because the filament's kind of enclosed in this one, but it is glowing. So on all of the sections, the shorts test, the one that's going to make it glow, is number 7. So number 7, yep, that makes it glow. And all the rest should not make it glow. And the last tubes we need to test are 3 6K7s. And those are used as the first IF tube, the RF, and the first detector tube. And these are all single section tubes, so these should go pretty quickly. And the filament is glowing on the tube. That means it's not open. And the short test for a 6K7 is lever number 7 makes the lamp glow. And it does. Test the other ones. Good. And the emissions. Oh, well, that's not good. Okay, here's another 6K7, and this is a metal tube, so we can't see the filament, but we can test it for shorts, and so that makes the lamp glow. Oh, that also makes the lamp glow, because 7 should make the lamp glow, and that's what it's doing right now, but 8 is also making the lamp glow very dimly. So this tube is shorted. Let's see what the emissions test says. Well, it's in the good, but it's not super in the good. It is kind of warming up. Well, as it sits here and bakes, the emissions test keeps going farther into the good, but I don't trust this tube because it seems like it has a short in it. I want to see what the gas test looks like on one of these. So to do that, I have to flip lever 10 down. Okay, gas test is fine, but the tester says it has a short. Okay, let's try the third 6K7. See if this one's actually okay. I see filament. I'll let it warm up for a second. Let's see if this one can pass the short test. So that's correct. This one does not have a short. It does a brief glow, which is normal, but this one doesn't show up as a short on that one. Let's check the rest. Okay, so that's more promising. What about the emissions? Okay, and it's going up as I let it bake. So I think this tube's fine. It probably hasn't been ran in a long time. See if the tube is gassy. It's not gassy. So this one seems like an okay tube. All right, so I've been doing some basic testing and checking and looking things over inside the radio just to make sure that all of the parts were accounted for and that they were all the right value and hooked up to the right spot. And for the most part, they are, but there are definitely some things that I don't like in here, and I'm going to clean up this chassis a little bit when I restore it, and some of the parts are going to need to be changed or replaced because not everything is correct, but this radio is not as bad as I would have expected. I went ahead and I tested each of the resistors off camera, and I wrote down all the values that they should be, and these are the measurements that I actually got. So you can see some of them have drifted. A 25K went up to a 33K, a 2.5K went up to 3.2K, so some of them didn't drift very far, but I did have one that went from 300K all the way up to 640K. That's over a 100% difference. And then I also had one that was a 20K, and it still measured 20K, so that one's perfectly fine, but a lot of these have drifted out of their tolerance, so I'm going to replace quite a few of them. And looking through the schematic and comparing to the radio, I also found a couple capacitors that were the wrong value, like C28 and C30. I marked those as having the wrong value, so I'm going to have to change those out because I think this one here is a point, what does the schematic say, 0.002, and I think the one in here is a 0.02, so this is wrong, and then there's another one that had a similar thing going on. And then I found a resistor that was missing. There's supposed to be a 235 ohm resistor tied from one of the ends of the speaker field coil to ground, and that's not there. The speaker connection is here, and I found the lead for the other end of the speaker coil that's attached to this connector, and there's not a resistor there. So I'm going to have to replace that with a new resistor. And then all the resistors I marked with a dot are ones that are out of tolerance and need to be replaced. So you can see most of them are. And I also wrote down I needed to upgrade R5 to a higher wattage resistor because it's a 16K ohm 2 watt resistor. And R5 is this big resistor here, and you can see how it's all black and burned up. It tests fine, but the outer shell is starting to crack and it's all burned up. So that thing must get really hot. So I'm going to upgrade that resistor to a 5 watt resistor. So hopefully when it gets hot, it won't get as hot and it won't get all burned up like this. The only other thing I noticed that wasn't correct when the restoration was done before is this capacitor isn't supposed to be here. It's just supposed to be a direct connection from this wire to the middle lead on the volume pot. So I'll take this out, but other than that, everything else in here was done pretty much correctly. The substitute electrolytics that were put in here are a little higher than the factory values, so I'm going to change those out to be just a little bit smaller. But all the other caps, besides those few that I encountered, are absolutely correct, and they were soldered to the right places. There's not a whole lot that I have to do here other than swap out a few parts, swap the bad resistors, and just clean up the chassis a little bit. So for example, here's something I found that bugged me to no end when I was trying to find all the resistors in this radio to test them. This resistor is supposed to connect to this pin of this tube and pin 3 of this tube. But instead of having a direct connection between those two pins, they have it just soldered floating in the air, and then they have a wire going to that pin. And I don't know why they need to do that, because you can just take the resistor and go directly from here to there, and then this capacitor that goes from it to ground can just go between that pin and whichever pin of the tube is connected to ground. So that setup could have been made a whole lot cleaner, and I found a few instances of that I'm going to address when I rebuild this chassis again. So it should look a little bit cleaner when I'm done. And I also went ahead and ordered all of the correct tubes that I needed for this radio. 4 out of the 7 were good, as you've seen. The 6B7 was shorted, and 2 of the 6K7s, 1 was weak and 1 was shorted. So I went ahead and bought 2 6K7s and a 6B7, so the tube situation on this radio should be perfectly fine after that. And one other thing I did is when I was looking for the riders and the service data for this radio, I could not find the data and schematic for the chassis 7JM. I could find it for chassis 7J, and that's what all of these radio models use. Mine's a 62175. But after doing a lot of research and looking through different schematics to see what was different and what matched this radio, I figured out that the only difference between the 7J and the 7JM chassis is that they updated some of the tubes to be slightly more modern versions. So I went ahead and modified this schematic to match a 7JM chassis to the best of my ability. And I relabeled the tubes that needed to be changed. So we have 3 6K7s. Those are different than what the 7J chassis used. And the same goes for the 6F6 output tube. And since these more modern tubes have a different number of pins, I went ahead and labeled all of the pins on the diagram of the tube, just so that you would know where they're going and you wouldn't have to check the radio as much. And pin 1 of the 6K7 goes to ground, and that was not present on the older tube. So I added a line from pin 1 going to ground for all of the 6K7 tubes. And so those are now updated for the schematic, and I did the same for the 6F6. It's got a different number of pins, so I labeled those, and then I found the ground pin, which is also pin 1, and added that. And I also went ahead and labeled the pin numbers on all of the pre-existing tubes so that the schematic would be a little easier to follow. And this matches the 7JM chassis as far as I know. And this radio had several pages of service data as part of the riders. And I also modified the second page here. There's a total of 4 pages. This tube layout in the original 7J riders was a bit different. And this chart I copied from a later Wards Airline chassis that uses the updated tube layout right here. And this is also a picture I copied from a later Wards chassis. But the original paper that was in my radio has a matching image. So I was able to just copy that right in. And so it now corresponds to a 7JM chassis. And this chart actually does tell you the tubes they used to use. And so if you're looking at the 7J chassis, it will use 6D6 tubes instead of 6K7s, and it will use a 42 instead of a 6F6. Everything else is pretty much the same. And everything else on this page I left the same because it's all the same. The only difference is the tube layout and this chart. So I updated both of those. And then the only other modification I did was on the last page where it talks about how the radio works and how to align it. I just removed and replaced all of the references to the older tubes with the newer ones. Like, for example, it talks about one of the 6D6 tubes here originally. And so I just changed all of those instances to 6K7, and I did that to all the rest of the newer tubes. So wasn't super hard to modify, but if anyone wants me to scan that in, let me know. And so because this radio has been rebuilt already and all of the capacitors have been replaced with modern ones, all of these capacitors are going to test perfectly fine and they're not going to be leaky. But we do still have two original capacitors, these huge, massive things. These are what capacitors looked like in 1935, and because they're so huge, they're held in with nuts and lock washers and screwed right into the chassis. So in order to test them, I'm going to have to take this one out because it's connected to the chassis, but this one has a little grommet between the chassis and itself, so it is isolated from the chassis, and the new parts they installed on a separate terminal tie strip that is isolated from the capacitor. So this one I can actually leave right where it is and test it, but this one, since it's still attached to the chassis, I'm going to have to take it out. So let's go ahead, for the fun of it, and put these under the leakage tester. And so after removing this capacitor, now you can get a sense for how absolutely huge it is. This is a Sprague 600 line dry electrolytic capacitor, and it is a 16 microfarad, 500 volt DC cap, but it is rated for a 600 volt DC surge. So when it was new, it could take up to 600 volts for a little bit, but it is only rated for 500. So this capacitor is extremely old. It's 91 years old, and there's no doubt it's leaky, but I want to apply power to it anyway just to see how bad it is. And because whoever was in this radio last cut the wires of this capacitor right down to the outer shell, I had to trim this little rubber grommet that surrounded the wires down a little bit and cut away some of the excess wire sheath just so my tester leads could bite onto it. So I think I have a good connection now. So now let's go ahead and test this capacitor. Right now it's not receiving power, but we're going to test its capacitance, and it should be a 16 microfarad capacitor. So I'm going to flip my tester into the bridge position, and now there is power going through that cap. So I'm going to turn this, and we're going to see if when it gets to around the 16 microfarad mark, if the eye tube opens up. And yeah, it's not opening up. I pretty much knew that was going to be the case. I'm going to flip it to discharge, and I'm going to flip it now to leakage. I have the tester set to 3 volts. Let's see if it leaks. Nothing. I might not have a proper connection on it, but we'll see. This cap is rated for 500 volts, so it can go up pretty far. Oh, wow. Okay, so we're at 15 volts, and the eye tube is closed. And if the eye tube stays closed like this indefinitely, that means the capacitor is leaking, because how these testers work is as the capacitor is charging, the eye tube will be closed, and then once it fully charges, it will open again. And because the eye tube is still closed, that means this capacitor is leaking. What a surprise! It's 91 years old, and it leaks at only 15 volts. And so the capacitor right now is passing DC through into the tester, and capacitors are supposed to block DC. And so that's what it means for a capacitor to be leaky. So this capacitor is no good. So the other capacitor is a little bit different. It only has one wire coming out of the middle, and that's because they used the outer case of the capacitor as the negative side. You can see this little lead right here. That's attached directly to the outer case of the cap, and so they used that as the negative, and so the part that's coming out of the end here, that's the positive. So I can just hook my tester between here, because the terminal tie strip is isolated from that, and hook the negative up to that little lead down there. And with the tester connected to the cap, let's see if it fares any better than its brother. So I'm going to flip it to bridge mode, and this is a 14 microfarad cap. Let's just turn the knob here and see if it registers anything at all. And surprise, surprise, it does not. These things probably haven't had power run through them for a really long time. So let's test leakage. It's not leaking at 3 volts. That's 6 volts, 10 volts, 15. That's kind of odd behavior. You'd expect a little bit of activity out of that eye tube. Yeah, that's not normal. I just turned it up to like 100 volts and there was zero activity out of the eye tube. And I have a firm connection to both of the leads on that cap. So that capacitor might be open. I mean, that's not out of the question. What we can do to check that is put this thing back in the discharge position and flip it to the resistance scale, because this can also test resistance. And so if I flip it into bridge, I have it set for R times 10K. And so we'll know if it's open if we measure resistance by turning the knob for different resistances. And if that eye tube stays closed, then we know the cap is open. And yeah, that's completely open, because right now I have the marker pointing at 5K and I have it set to R times 10K. So it's pointing at the 50,000 ohms mark, and we're not getting any resistance. So that capacitor, I'm pretty sure, is open, because if the capacitor were leaking, then it would develop resistance, because when a capacitor leaks, it's basically the same thing as putting a resistor in parallel with the capacitor. And so you would be able to measure that leakage using an ohm meter or a resistance check. So I'm pretty sure that that capacitor is open. So that one is even less healthy than the other one. And I'm sure some of you are wondering why those capacitors are even still in the radio. Why wouldn't the previous owner have removed them when rebuilding the radio the first time? Well, that's because they wanted to preserve the original look of the radio. So that way, when you look through the back of it, you still see the capacitors and the radio looks all original still. But inside, they took both of those capacitors out of circuit, so they're not connected to anything anymore. There's no power going through them. And I'm going to be doing the same thing. I'm going to leave both of those in there to preserve the original 1930s look. And I will just be fixing up the chassis and cleaning it up and making sure all of the new parts are okay. So now it is time to do the chassis rebuild. I've got all of my parts in and I'm ready to actually restore this thing properly. Although there were a couple more things that I've noticed when looking around in here. The first thing is that this lug on the speaker connector isn't connected to anything, and I can tell it used to be because there is some solder residue on it. And so, because the service data doesn't give you an actual pinout for that connector, I went and made the pinout myself. So for the top two lugs on that connector, and that's looking at it from this pin that's kind of off by itself as the bottom pin, so these two lugs here, those have a yellow wire and a black wire on the plug that's inside the chassis going to the audio transformer and the speaker. And then because the other three wires on that plug are so faded, I can't really tell what color they're supposed to be, I just labeled them left, right, and bottom, and I wrote down what they are actually connected to in the schematic. And so the black and yellow go to both ends of the speaker coil, which is attached to the speaker inside the chassis. And the other three wires, the left and right, go between the two input ends of the audio output transformer, and the bottom is connected to the ground inside the middle of the transformer. And so that is the pinout for that connector. And so what I need to do is just hook up this lug to this ground point here. And because this capacitor is incorrect when I put in the new one, what I'll do is I'll just have the cap go through this lug and solder it to that, and then also solder it to this ground. And so that will restore the ground connection on that pin. And so that will be all fixed. And the other thing I noticed was, you remember how I said that there was a 235 ohm resistor that was missing? Well, that resistor is actually this little thing right here. And at first I thought this was just some sort of metal bar that had ground connections on both sides, because you can see this part is tied to the chassis, and I assumed this side was as well. But if you take a look close in, you can see the terminal on that side is isolated from the metal enclosure. And so I measured the resistance between those two, and I got 239 ohms. So this is the 235 ohm resistor. And since it's measuring 239 ohms, it is still perfectly fine, and I'm going to leave it inside the radio. So that's actually the resistor there. So now I'm going to go ahead and rebuild the chassis and clean some things up. Like, for example, we have a transformer lead going out to here and then another wire just going to this point. Why can't we just have the transformer lead go from the transformer to that point? It looks like it's long enough. So things like that I'm going to clean up. I'm going to make it a little more simple, and it'll look somewhat neater in here by the time I'm done. Well, after looking at the speaker again in a little bit more light, you can see it has had some damage before. You can see a big tear mark right there and right there. It has been glued together, so when I push against the cone, you can see the entire thing is moving as one piece. So the tear shouldn't be a problem anymore, and there's another little tear mark over here that I can tell was glued on the other side. So I don't think this is going to be a problem, but I'll just have to be careful when driving the speaker. I don't want to have it vibrate too much. But I have gone ahead and I finished rebuilding the radio chassis. So here's the top side. I went ahead and gave it a nice clean, so it's looking very good now. And I replaced all of the shorted and weak tubes with nice strong ones. And so now all the tubes are going to work just fine. And if you remember from the beginning, this radio was missing 2 of its tube shields. But I went on eBay and saw that someone was selling a box full of just various tube shields. And it just so happened to be that 2 of the tube shields matched exactly with the tube shields that were in this radio already. So these 2 here are ones I bought from eBay, and they're exactly the same as the ones that it had. So now every socket that can support a tube shield now has a shield. And here's what the underside of the chassis looks like after I finished rebuilding it and replacing all of the incorrect and bad parts. So you can see it looks a little different. I've kind of consolidated everything a little more close to the edges, so it has a bit more of a cleaner look. And perhaps the best simplification I was able to do was take this transformer wire and have it go out to this lug right here. And these 2 little electrolytic capacitors, those are the replacements for the big, huge 1930s capacitors. So now they're even smaller, and they can just attach right to lugs on the speaker output plug, and so that makes it look very clean. And I've also changed where some of the components attach to the chassis. So for example, there's a capacitor kind of over here before, and it attached to ground all the way over here where this blob of solder is attached to these wire shields. I figured, why not attach them to the ground lugs on the tube sockets, so that way I can trim the lead length down and keep the components as close to where they need to connect as possible. And so I think it achieves a more cleaner look. And there were a couple instances where there were 3 components connected together with a solder blob in the air, and I didn't really like that. So for those connections, I decided to use these little screw terminals so I could have one component going into one side and then 2 other components going out of it, just so it can be more out of the way and not in the air. And then I used some UV curable resin to glue these terminals to the chassis. And so you can see I've done that in 2 places. And so I think that looks a lot better than just having a solder connection floating in the air. And so that is what the inside of the chassis looks like now. I've replaced every capacitor and resistor except for this one here because it still measures spot on what it's supposed to measure. But everything else has been replaced. These 2 micas are original, but I imagine they will be just fine because those rarely ever fail. And so that's the chassis. I was even able to eliminate 2 wires from the circuit just because they were redundant. They weren't really doing anything, just because of how the previous owner wired it up before. So I simplified the circuit and made sure that it still matches the schematic. So now we're ready to put this chassis back into the cabinet and see if this 1935 radio will work once again. And I should also mention, off camera, I did some resistance tests on each winding of the main power transformer. and all the resistances were spot on. So the original power transformer with this August 2nd, 1935 date code is still working absolutely fine. So I shouldn't see any issues with that when I plug it into power for the first time. But you're probably seeing these new white rubber feet on the corners and wondering, where did I get those from? Well, if you watch my channel on a regular basis and you know what type of content I mainly put out, you might have an idea as to what those are. Pinball rubbers. Yes, those are pinball machine rebound rubbers. They happen to have the exact dimensions to fit on these little metal pieces, and the curvature of the rubbers matches exactly with the curvature of those metal pieces, and they make perfect replacement feet. And you can see they even match the same height as the chassis itself, so the radio will rest on those feet. So that was a really good discovery that I made, and I was able to replace all of those decrepit rubber feet that it had before. And so now it is time to test this thing out. So the setup I have here is the radio is plugged into a variac, and that's plugged into an isolation transformer, and then that is plugged into the wall. And because this radio doesn't have a built-in antenna of any kind, I have a long wire connected to this wire, which is the antenna wire, and then I have that kind of just going up high, up to that little window up there. So I should hopefully get some reception by hooking it up like that. So we'll start this test with a rear view just so we can watch the tubes glow, because isn't that always the fun part, to see if your heater line is working? So what I'm going to do is, right now I have my variac set to 0 volts, and I'm going to turn it on. So now the variac is on, and it doesn't have a short because the variac would have popped the fuse, so nothing in the radio is shorted. So what I'm going to do is turn the variac back off, and we will start with around 20 volts. So the variac is now set to 20 volts. I'm going to go ahead and turn it on. So now we have power flowing through the radio's power cord into the radio, but the power switch on the radio is still off. So I'm going to go ahead and turn that on, and we'll see what happens with 20 volts being applied. Okay, I'm watching the current meter on my isolation transformer, and it's drawing about 100 milliamps, so there's a little bit happening, but I shouldn't really see much of anything. I'm just trying to bring it up slow in case there is a problem. I don't want to just dump 120 volts into it right away. But we don't have any serious problems because we don't have any explosions. The variac and isolation transformer is still running. Seems like everything is okay right now. You know what? I can actually see one of the dial lights is lighting up ever so dimly. It is really hard to see, but I can see that it's glowing a tiny bit. So now I'll turn the variac back off, and I'm going to set it to 50 volts. And we're still drawing around 100 milliamps. So it seems like it's able to handle 50 volts. And you can see that the dial light, there's 2 dial lights, and they do both work. I tested them with my power supply. Those are lighting up a lot brighter. And I am starting to see some faint glow out of the tubes. So now we're coming into just a high enough voltage to where the tubes are starting to conduct. All right, I've let it sit for a minute, and things still seem like they're going fine. So I'm going to go ahead and turn the variac off. Now we'll go up to 80 volts. Okay, now we're drawing at least 300 milliamps. So things are really starting to happen now. And I do hear a little bit of hum out of the speaker. It's very faint, but I do hear it. So I'm letting it sit, and now the radio is drawing at least 700 milliamps. My isolation transformer is only accurate down to 1/10 of a decimal, so it says 0.7 amps. So It is certainly drawing some current now, but everything seems like it's okay. So I'm going to go ahead and shut the variac off, and we'll turn it right up to 120 volts. And so now I'm going to turn it back on, and the radio is going to receive full power. Oh, we just got some smokage. Look at that. Well, it wouldn't be a repair video if we didn't let out the magic smoke at least once, right? So I took a look inside here to see if I could find anything obvious that went wrong, and I found it pretty quickly. This capacitor, this is the first filter capacitor. It comes right off of the B+ on the transformer, and it goes to one of the pins on the rectifier tube. I installed it backwards, so it was making the 80 rectifier tube red plate and start smoking. And the capacitor, I don't know if you can tell from this angle, you can see it's a little bit bulged now. So if I left the radio on any longer, that capacitor would have exploded. So I need to put a new cap in and install it the correct way. This other electrolytic up here, it was installed correctly, so I just made a mistake. So that just shows you what can happen if you install electrolytic capacitors backwards. And I put the 80 back in my tube tester to see if it was still okay, and it is. Both of the two sections still test just as strong as they did before. So the tube did not get destroyed, and so I should be able to just swap this cap, and it should work fine after that. Okay, I installed a new capacitor and made sure that it was in the correct direction, and so now everything should work fine. So I'm going to test this out of the chassis, not hooked up to an antenna and not hooked up to a speaker, because I just want to monitor the current right now and just see how everything runs. So right now I have the radio plugged into my test setup, and I'm going to turn on the variac. The radio is off, so nothing should happen until I turn on the power switch. So I turned it back on. I just want to make sure it doesn't red plate and smoke again. All right, things seem like they're a lot better because now I'm letting it sit, and we are only drawing 100, almost 200. I've seen it go between 0.2 and 0.1, so around 200 milliamps, give or take. That is a lot more normal. So everything seems to be fine. I see glow out of the tubes. The 80 isn't red plating and overheating. So now I'm going to shut it off and put it back up to 120. And now I'll turn it on again. Current is around 300 milliamps. And I'm just going to watch that 80 tube. I see the filament glowing on it, but it's not red plating like it was before. Everything looks normal to me. No smoke. The 80 is still not red plating. So I think that was the problem there, just I had the cap backwards. Never mind, I let it sit for like 2 minutes on 120 volts and it started smoking again. So something is obviously more wrong than just that one capacitor. All right, I think I see what my problem was this time. So when I powered it up this second time, I didn't have that rear speaker jack connected that goes to the speaker and the audio output transformer. Well, what happens when you power it up like that is this coil, L2, this is the big huge coil that's on the back of the speaker, it gets taken out of circuit, and this wire here is the high voltage center tap. And so when you remove this from circuit, the high voltage has nowhere to go back to ground. You can see it goes through the coil and then through this resistor to ground, and then it also can go this way to ground. So with that speaker plug disconnected, I think the voltage can just kind of float and go into a thermal runaway. And so I think that's why the capacitor smoked the second time, because what I've been doing is I have removed the 80 tube from the radio and left all of the other tubes in place, because this radio, the filaments are wired up in parallel, so even if you remove this tube, the rest of them will still glow. And so what happens when you remove the 80 is that the high voltage goes up to these pins but it has nowhere else to go. So the radio is not getting its B+, and I've been powering it up like that with a new capacitor and the 80 tube removed, and I've had no issues. Everything comes on, the tubes light up, and the transformer does a very quiet hum, and there is no component getting hot or smoking. And I know this setup looks kind of precarious, but what I'm doing here is I reinstalled the 80 tube. I have the speaker voice coil and audio output transformer actually connected this time, so now the high voltage should be able to make its way back to the chassis. But I hooked up a voltmeter across the capacitor leads, this vacuum tube voltmeter right here, so I can see the voltage going through that cap, because if it gets to be anywhere higher than 400 volts, I'm going to shut it off right away because I don't want it to smoke again. So I'm going to be monitoring the voltage as well as the current through my isolation transformer, and we will see what happens this time. So I'm going to go ahead and power up the Variac, and let's see what happens. It's drawing an amp. Okay, I turned it off. Let me just touch that capacitor. Don't do this if you don't know what you're doing. I want to see if that cap got hot. No, the cap is not hot. Of course, that could be just normal hum coming out of the speaker. And this radio is from the 30s, and it's a pretty beefy radio, so maybe an amp of current draw is normal. And you saw that it was drawing an amp, and it didn't keep climbing higher, so that's a little bit reassuring. And I find it a bit weird that my voltmeter isn't registering any voltage, but I think what I'm going to do is run it at full line power for at least 30 seconds because I want to see if the current draw goes down after everything warms up. So I have the power switch in the Variac right close to me, so if something happens, I can shut it off immediately. I'm going to turn it back on. Because that doesn't sound bad. It's just a quiet hum out of the speaker, and the current is not climbing. Okay, that's long enough for a test. So the current didn't climb. Let me feel that capacitor. Not hot. Okay, so I'm a little less concerned. Well, I don't know what's wrong with me today, but I know why it's not measuring voltage, because I'm using the wrong probe. I'm using the probe that's designed to measure AC. I'm not using the DC probe, because I bought some aftermarket probes for this VTVM because I don't have the originals. And the original one would have had a little switch on it, I think, that would have swapped it from AC and ohms to DC. But these aftermarket ones, they're two separate probes. So I need to hook up the DC probe. All right, let's try that again, see if we get voltage this time. Still no. Yeah, I don't like that. But we're not smoking. Well, we are getting B+. I'll go ahead and turn the radio back on. It's under full power, and I'll show you what that looks like. So there's our high voltage, and we're running on 120 volts. And this is hooked up directly across that capacitor that was smoking, and it's rated for 400 volts. So obviously, when it was smoking like that, it was getting a whole heck of a lot more than 400 volts going through it. But that B+ level looks good. You can see it's still climbing, but it's starting to settle off. And so that means that the 80 rectifier tube is doing its job, because if it wasn't, we wouldn't be seeing this high voltage. So we know that that portion of the circuit is working. And when I had it in that powered up state, I did hook up an antenna to it, and I didn't hear any stations. I didn't hear it trying to receive at all, because when you turn the volume pot and the tuning knob, you'd expect to hear some crackling just coming from the pots as you turn them, and I didn't hear any of that. It was just a constant hum out of the speaker the whole time, and that hum doesn't change when you turn the volume up and down, and it doesn't change when you switch between shortwave and AM. So we know that there's still a problem, but the B plus is working, so we know that the high voltage is being spread all throughout the radio. So obviously there is another problem that we're going to have to address. Well, I think this video is getting a little bit long, so I'm going to split this one into two parts. So we managed to answer the question, will it run? And the answer is yes. And so in part 2, we'll be answering the question, will it receive? So stay tuned for that, and I will see you in my next video.